Okay, so Active Directory. This is a bit awkward because I actually put together some stuff on x86 instruction set since that was the talk that was going to be up here before. But I'm guessing that's not what I'm actually going to do. So let me just go through these and this and that. Oh, sorry. That was actually really cool. That's something you should probably look at later. Pack bits are awesome. Definitely check those out. Yeah, we got that. Sure. Bitwise logical XORs. Anyone? Anyone? Yeah. Okay, there we go. All right. So let's talk Active Directory security. I'm Sean Metcalf. I'm the founder of Trimark Security Company. I work with a number of companies, a number of organizations around the world to help them better secure their environment. Microsoft Certified Master in Active Directory. There's about 100 in the world. I've spoken at a number of conferences, including ShakaCon here 3 years ago, so I'm very excited to be back. And I'm an AD enthusiast. I'm very much excited about Active Directory. I'm excited to talk to companies and customers about what they're doing and their challenges. So we're going to go over the current threat landscape, cloud Active Directory. What does that actually mean? The typical security issues that I've seen at customer sites and organizations and how to fix those, clean them up. The ever-evolving and expanding set of permissions that tend to just take over Active Directory over time. Some cool attack detection, and then wrap it up with some recommendations. So breach. I love doing searches on Google that are just very simple like this, and apparently there's like 4 million breaches out there, according to the Googles. But the state of security is good, right? So we got some good. Better security awareness. We're able to see what's going on better than we have before. We're getting some logging. We're flowing it in. Sometimes we miss the elephant in the room, but that happens. We have better security testing. Pen testers, red teamers have really evolved and are looking at what some of the more advanced persistent threats are actually doing out there. And better PowerShell security. So if you haven't already rolled out version 5, please roll out version 5. It's awesome. And apparently the same thing in Python is coming to Python v3. We're looking at similar types of logging and security capability there that we already have in PowerShell. So that's pretty great. But we also have some grumpy cat news, unfortunately. Going from a user to an admin is still way too easy in most environments. All someone has to do is basically put on the outfit, and then they're the admin. Legacy really reduces security. Legacy is probably one of the biggest issues that we have today, the FUD that's associated with it. You have this service account, it has a domain admin, it doesn't need that. Well, this is how it's always been, and Joe set that up. Well, where's Joe? He left 5 years ago. Okay. PowerShell logging not enabled. So we've got all these great new features in PowerShell 4 and v5, but the logging is just not enabled. It's just pretty basic, simple group policy configuration. And there's still too many blind spots. One of the great things about having a pen tester or a red team come in is to identify those blind spots, those areas you can't see. If you can't already see those, they're just going to come in to confirm your suspicions. And of course, we've got to talk about the ugly. Email gets users to click. Why is this? We have trained users to click for years by sending them internal email. Click here to update this, click here to update that. We have performance reviews that we have to do. Click here to get to that. Click here to get to this. Click here to see the dancing chickens. And from email to breach is way too easy. We end up with a situation where we have Predator hiding on our network and we can't see it. And a year ago, there was an article that said that nearly half of firms had a cyber attack or breach, which is pretty bad. And this was in a year that about $80 billion was spent on cybersecurity. So how does that make me feel as a person who works at a company that works with other companies? I kind of feel like when you're talking about $80 billion, you're talking about taking a dollar stacked end to end and then going 16 times back and forth. That's a lot of money. And then in 2018, how much money are we burning through this year for the blinky boxes? It's a challenge. And so now we have this whole cloud thing where it's rainbows and unicorns and everything's happy and wonderful, right? There's a lot of challenges, though, because we have our on-prem environment, which we're very familiar with, probably, and certainly more familiar than a cloud environment. We know how to control egress, ingress in our own environment. We know what things look like. We know what the problems are. We know we can see. Hopefully we know what we can't see. But it's always changing in the cloud world. I go and read documents that are 6 months old, and then I've got to go and read new documents because a lot of things have updated and changed. This means that learning curve is a lot steeper than it used to be, and certainly steeper than it was for other technologies. And the security capabilities and the ability of that cloud environment is very much dependent on the provider. So if you're with Amazon or Microsoft or Google, there's going to be differences in how you can secure different things, how you can control access. And there's even different names for different things across those different cloud environments, which makes it even more difficult. And then, of course, it's not always obvious what you're sharing versus what you're not, or if you're sharing it internally versus public. I think most people here know what the word or the term S3 means, right? Because we've seen it in the news all the time. The one thing that I've heard a lot, though, is I'm going to migrate my on-prem AD to Azure AD. And it doesn't quite work like that. Azure AD, despite the fact that it's Azure Active Directory, is not Active Directory. At least not the way that we're used to, or the way that we're used to thinking of it as. We're not going to just shift and forklift what we have on-prem up into the cloud. That's not Azure AD, at least not today. We have our on-prem AD, which we're very familiar with. We have authentication, directory, management services. We have authentication, Kerberos and NTLM. We know that pretty well. Certainly the attackers know these pretty well. We can use LDAP to query it. We can use group policy to help manage our systems. Azure AD is quite a bit different. It's an identity multi-tenant cloud directory. And it's cloud and web focused, which means that the authentication is very different as well. We're looking at OAuth, OpenID, Connect-based authentication and protocols. We're not looking at NTLM. We're not looking at Kerberos. Those things don't exist in Azure AD. And if you want to use LDAP to look at Azure AD, you can't. You have to use the Active Directory Graph API. And if you're looking at doing some sort of management of devices, sure, I can join my computer to Azure AD. Where's the group policy? There's no group policy. I've got to then get it configured with an MDM, something like Intune, which isn't quite group policy. It doesn't have the same exact feature set. Today, I can't go into Intune and configure the security settings for Windows 10 like I can in group policy. So this is what Active Directory using computers looks like. We're very familiar with this. We have used this. We've seen this. With Azure AD, it's a web page or PowerShell. Very, very different. We have to think about this differently. It's not a situation where we're just going to push all of our systems into the cloud. Now, moving email and data and in order to share and in order to collaborate better, that makes a lot of sense in the cloud. But these workloads that we have that use NTLM and Kerberos for auth, we can't just shift those over to Azure AD. So there's some key points here that Azure AD is cloud authentication. That's what it's primarily for. And as I mentioned, there's a number of things that are differences between Active Directory and Azure AD. And there's a reason why I say Azure AD and not Azure Active Directory, because it's not exactly Active Directory. If you want an Active Directory in the cloud, that's quite a bit different. You have to go with something like Azure Active Directory Domain Services from Microsoft, or Amazon's Managed Microsoft Active Directory in the AWS cloud. I had to make sure I read that correctly, because that's a mouthful. But Microsoft's Azure Active Directory Domain Services is your cloud-hosted Active Directory. It has some interesting OUs here, like AADDC computers, AADDC users, AADDC domain admins. These are delegated OUs. You're not going to be a domain admin in this hosted environment. And there's some differences with it. But this is the AD as a service if you're looking for that sort of thing. But again, this is a little bit different than what most people think it is. Azure AD Domain Services is not meant for you to set this up and then use it in order to configure a forest trust from your on-prem AD. It doesn't support trusts. This is primarily for managing your Azure workload, your cloud workload. You get group policy and all the other things, but you're not a domain or enterprise admin. And you're not going to have direct access to those domain controllers. So again, even with AD in the cloud, it's a little bit different than what we're used to. Now, when we're talking about Active Directory and the connectivity with the cloud, AD provides us single sign-on services, and there's sync tools that enable you to take users and user data and then sync it up to whatever that cloud service is. A lot of people have probably gone to a company and they have the little iPad and you touch the information and it has the information about who you check in with. Well, guess what? That information gets synced from that on-prem AD to that cloud provider. There's a lot of others that do the same thing. And these rights that are required in order to do this are just user rights in AD. So the real question is, how many of these sync tools do you have in your organization that you're aware of? Well, there's Azure AD Connect, which if you have Office 365, you probably have Azure AD Connect, because that's how you synchronize your user and groups up into Office 365 and the Azure AD tenant that's spun up automatically for Office 365. And primarily what this is used for is in order to make sure that the user accounts that exist on your on-prem AD are also in Azure AD. And you have group membership that gets updated as well. And you have the ability to do what Microsoft is calling here password synchronization, which is not entirely accurate. It was called password synchronization. It's been called password hash synchronization, which isn't entirely accurate either. Basically, it's an Active Directory password hash. So they take the password hash of the user account, they hash it again, do some additional crypto on it, and that's what's actually sent up to Azure AD. And there's also the capability to do write-backs. So that way, when a user auths to Azure AD and their password is expired, they can update their password in Azure AD and then have it sync back down to their on-prem AD environment. And if you have Azure AD Connect and you've gone through and hit the easy button and had it do the express settings, it would set up all of these different permissions for you automatically. But there's something interesting about this here, and I talked about this at DEF CON last year with Gerald, that there's two rights here that are provided to the service account for Azure AD Connect, replicate directory changes and replicate directory changes all. These two rights provide the ability to pull password hashes. Well, that makes a lot of sense under the context of Azure AD Connect when you're actually synchronizing that password hash component up to Azure AD. But what if you're not? Well, that's not necessary, right? And there's this little thing called DC Sync that's part of Mimikatz now that provides an attacker with the ability to take over this account or to have these two rights without domain admin rights or enterprise admin rights to actually synchronize and pull password hashes from the environment. So we want to make sure that if we have Azure AD Connect and we have service count for that, we're really well protecting it, because effectively it's like being an administrator, an AD admin with access to the crown jewels. So custom permissions would be definitely the way to go if you're not planning on synchronizing the password data. And certainly a few months after that, in December of last year, Microsoft put out a security bulletin highlighting the fact that account operators has the ability to take over that account based on the default install of Azure AD Connect. Hopefully no one in here is using account operators, and we'll talk a little bit about why that's not a good idea, actually, to have that configured. So the Azure AD Connect server is about every 2 minutes, it's requesting the stored password hashes from Active Directory and taking that onto the server and then doing some crypto on it. So it's taking that MD4, it's then doing an 8-bit binary hash, which is converted to a 64-bit binary, setting a 10-byte salt, and then creating a 64-bit hash, which is then input into SHA-256, which is pretty strong. So that's sent up to Azure AD, and that's what is used to compare to when a user actually authenticates to Azure AD. So that way they don't have to come back into the on-prem AD in order to auth and then get to federation and other things that they have through Azure AD. So there's certainly some very strong recommendations that I have here. Basically, if you have Azure AD Connect in your environment and you have that server and you are synchronizing the password data, you want to protect it like a domain controller. The other thing that's interesting, in a lot of environments that have multiple forests will actually have one Azure AD Connect server for it. So this server is not just like a junior domain controller, it's a junior domain controller for like all of the Active Directory environment. So we want to firewall this off, we want to protect it and keep the account operators group empty. There's also another thing that's pretty interesting that I talked about at DEF CON last year, and that was that federation is kind of like a cloud Kerberos. And so just like how you have to protect your KERBTDT password hash in Active Directory, you also have to protect your certificates that are installed on your federation server, like ADFS. So you'll definitely want to look at your ADFS server. If you have ADFS servers or other federation servers on-prem, you want to check to see who has admin rights to those. Check the local administrators group. You want to look to see who has access to those on the network. Certainly not everyone on your network should be able to connect to that server, because the token and signing certificates are effectively what are used to create those tokens or those tickets when you're dealing with federation. And then a few months after this talk, certainly someone figured out how to actually weaponize this and made what they called the golden SAML attack, where if they had these certificates, they could go ahead and create their own tickets and say, I am whoever I want to be in this environment, through federation, et cetera. So we find some really interesting things when we do Active Directory security assessments for customers. What are the things that attackers really require? Well, they need accounts, the credentials. They need the rights, the privileges associated with those credentials. And they need access, the connectivity to the resources. If you're able to disrupt any one of these things, the attacker is unable to do what they want to do in your environment. And one of the things that is very important to understand is even if you feel like I always have to be right, I have to be right 100% of the time, the attacker only has to be right once. Well, that's true for the initial foothold, once they get onto the network. But at that point, that entire paradigm shifts and turns around. Because now as the defender, you have the ability to configure and control your environment. Jessica Payne calls this building the attacker's playground. You can set it up and force these traps and tripwires for when the attacker gets into your environment, they have to go through these things, and you can get alerted on that. And at that point, the attacker has to be right 100% of the time. You just have to catch them doing something once. So, one big thing, as an attacker, do I need domain admin? No, not. There's rights all over the place. There's lots of things in your common, everyday Active Directory environment that provides escalation paths for attackers. There's a number of them. Here's a few of what we find regularly, and we go through and analyze these and talk to customers about how to tighten these up. And I'm going to dig into a few of these in more detail in just a second. Local administrator passwords not managed on workstations or servers. A lot of times the workstation build sets a standard, and it stays that way. So we compromise one workstation to compromise them all. You can use Mimikatz or something similar to dump the credentials off that local account database. And once we have that admin account password hash, we can then try it against all the other workstations. And a lot of organizations, that still works. So you definitely want to use something like Microsoft Laps or similar to make sure that those passwords actually get rotated and changed and are unique in the environment. But we also find the flip side with organizations that have Laps. Oftentimes they will over-delegate who has access to view these Laps passwords. So certainly, once you're changing them, you want to make sure that you restrict who has access to these passwords. Because the delegation of this access is critical. And we don't want to find a situation where ends up being 100 people that have access to the local admin passwords across all workstations or even across servers. The domain password policy by default looks like this. It's 7 characters. I'm sure everyone agrees that that's a great, really strong password. Yeah. So we're going to change that. We're going to make it better. We're going to make it 8. 1 better. Obviously, that's not a great setting. Not a great way to do it. 10 is much better. Set it to 12, preferably something more like 15. Microsoft did an update in April. So now using Windows 10 or 2016, you can actually set this within the GUI to 20. So that's a huge improvement from 14 to 20. So now we can actually start cranking that up to force longer passwords. And if you have a situation where you have a subset of users in your environment that just can't have 15 or 16 character passwords because of legacy requirements, you can also use fine-grained password policies to apply to a group that you put those users in, and they will still have 8 character passwords or 10 character passwords or whatever's required. So certainly a user in a domain admin group would be bad, but that still happens. Oftentimes, organizations have gone through the process of cleaning up and of shifting their old single account to a user account and an admin account, but a lot of times forgets the process of cleaning up those old user accounts. No naming account standard. I don't really know what the admin account standard is, but I absolutely know who the admins are because I know how to enumerate admin groups. This does not fool attackers. It's best to have a very standardized admin standard or naming standard because that way you can programmatically identify who's supposed to be in admin groups and who isn't. So designators that clearly identify admin rights, like something like -ADA for Active Directory admin. Default domain administrator account. So the default domain administrator account it should really be a break glass account, like only used if you really need it in an emergency. But I regularly find that organizations have set this as their SQL service account, which doesn't seem to make a whole lot of sense. But it's the admin account for the domain. And so it has a service principal name. And if the password hasn't been changing in years, it's probably very weak. And there's an attack method called Kerberos Sting, which enables attackers to request a service ticket for this account, because it has a service principal name, and then attempt to crack it offline. And all the password crackers now support this. And then, of course, service accounts and domain admins. So service accounts rarely need domain admin rights, despite what vendors say. Much better to delegate exactly what's required. And if your vendors say that their service account requires domain admins, ask them what the specific rights are that leads them to that statement. Push back on your vendors. As the customer, before you sign the contract, you have that ability, you have that power. A little more difficult once the contract's been signed. But we see this all the time where the vulnerability scanner is the account that's a member of domain admins because it's got to scan workstations, servers, domain controllers, etc. It's much better to split this out into separate accounts. Because what if this vulnerability scanner hiccups? What if someone does a code update to it and it hiccups and it leaves credentials behind on 1% of systems? These are domain admin credentials that end up getting left on a workstation. So we want to segment these off. We want to isolate and have an account for scanning workstations, one for scanning servers, and then a totally different one for domain controllers, if we even want to have that same system scanning domain controllers. Server GPOs linked to domain controllers happens all the time. We have a GPO that has a server policy. We link it to the domain controller's OU. It does many things, sets a security baseline, but one of the things it actually also does is adds the server admins group to the local administrators group. Well, guess what happens when we apply this to a domain controller? It takes that server admins group and adds it to the domain controller's local administrators group, which happens to be the built-in administrators group for the domain. So now our server admins are our Active Directory admins. So even if this configuration is not in place, we can also have a situation where there's a baseline security policy that someone's created. Nick is a great guy. He set this up for servers. Domain admins are like, all right, we got to set up some sort of baseline security policy for our domain controllers. So what are we going to do? We're going to take what Nick did and we're going to link it to domain controllers. The problem is that Nick still has modified rights to that GPO. Since he still has modified rights to that GPO, he can change a group policy that links and applies to domain controllers, which means that he can link a script that can install or run code, or roll back security settings, or add admins to the administrators group, or maybe someone taking control of his account could do the same. So we want to make sure that only your Active Directory admins have modified rights on these GPOs. And then cross-forest administration gets really tricky. We regularly see that there's production and there's external, two different forests. It could be production lab, it could be production and then something in the DMZ, it doesn't matter. There's a one-way trust where our external environment trusts our production, which is the standard Microsoft recommendation, because then our accounts in production can authenticate to the systems in external. The problem is that a lot of the times when this configuration is in place, the production forest AD admins manage the external forest. Well, that just makes sense. But guess how they typically do that? Via RDP. So when you RDP into a system, you put the credentials on that system. And when we RDP from our production AD environment using our production AD admin account, and we RDP into a domain controller or something else in this external forest environment, we are leaving those production AD admin credentials into that external untrusted environment. We don't want to do that, because all an attacker needs to do is compromise that lower trusted forest in order to compromise the production forest. So definitely we want to either manage our external environment with external accounts, or we want to use non-privileged production forest accounts with admin rights in our external environment, as long as we're not using the exact same admin account from production. So account operators, I mentioned this earlier. Account operators are a carryover from the NT4 days. We do not want to use account operators. They kind of have backdoor rights to user accounts and groups and a bunch of other things that we don't need to do anymore. It's much better to custom delegate a custom group to give it the access it needs. Microsoft even says don't use account operators. They say that it's a service administrator group because it can modify server operators. Leave this group empty. Do not use it. So I plead with you, do not use account operators. One action you can take when you get back to work, enumerate the membership of account operators. If there's accounts in it, figure out how to get them out. And then one of the other big problems is admin group nesting, where one group is in another group and is another group and another group. It is very difficult to determine who is really an Active Directory admin through this method. And we have incidental or unintended admins that end up in these groups because of this. And then one thing that we see a lot of the time is the default domain controllers policy is default. The same security policy that Microsoft configured and identified from Windows 2000 is still configured today. And no one has changed it. Or maybe they change it, and for some reason they add domain users to have the ability to log on locally to domain controllers. The user rights assignment component on GPOs that are linked to domain controllers is an untapped bounty for attackers. Admins very rarely look at user rights assignments that are configured on domain controllers. I know this because I look at them. It's one of the first things I look at. And then I can identify what other accounts and groups have admin rights on domain controllers or have the ability to log on to domain controllers. Because if I have this configured on a GPO that's linked to the domain controllers OU where server admins can log on locally or log on through RDP, and this is also configured where domain users can log on locally. This means that server admins, any server admin, can RDP into the domain controller and administer it, or at least manage it that way. So we want to make sure that only our AD admins are the ones that can manage our domain controllers. Here's a fun one. Exchange requires manage auditing and security log rights on domain controllers. And sometimes other groups get put in there as well, just because, like server admins. Well, anyone with the manage auditing and security log right can clear the security log. This is not something we want just anyone to be able to have. And if you've moved to Office 365 and you've cleaned up your environment, you definitely want to talk to Microsoft to see if this right's still required for your Exchange servers. But in the real world, rights are everywhere. Workstation admins have full control on workstations. Server admins have full control on servers. Server admins are Exchange admins. Sometimes server admins are domain controller admins. Help desk admins have local admin rights on all the workstations. There's local admin accounts and passwords that are same across multiple systems. And then we have temporary admin accounts. We need Mike to be able to do something, so we add Mike to this account, this group, and he's doing stuff, and we move on because we've got 10 priority ones. We move on to something else. And then we don't clean that up again. And I went through and looked at a lot of the third-party product permission requirements across a large number of products. And I came up with these seem to be the common ones across all of them. And as I kept looking at these and looking at them, my eyes just glazed over, but a pattern emerged. And hopefully a pattern emerges for you as well. Because as I started looking at it, I saw that over and over and over again, these products were requiring domain admins. Why? Because it makes it easier. It makes it easier from a development perspective. When they develop the product, domain admins just works for everything. From a sales perspective, here, install it this way, it takes 5 minutes. From a post-sales perspective, you have all the rights. Everything's configured for the product to work. There's never going to be a problem with permissions, probably. So everything just works. But this makes it easy for the vendor. It is way too easy for the vendor. I had a friend who was working at a customer site, and the VPN vendor said that their VPN service count needed domain admin rights. I said, why? That doesn't make sense. So we asked the VPN provider, and the VPN provider said, well, if a user's password expires, they can't VPN. We provide them the ability to change their password, so we need to be able to change the password. I said, okay, well, that's pretty easy. That's like one of the most basic things you do in Active Directory is delegating the ability to change the password. But there's also over-permission delegation where we use the built-in groups for delegation, or we click the easy button, so we do full control at the domain root. We just want to make it work. And the delegation tools in Active Directory are very challenging. I don't know if anyone has ever tried to use this to figure out what permissions are in their environment, but it's nigh impossible. Because just looking at this right now, there's a major security issue and no one's seen it yet. This is illustrating my point perfectly. Here, I'll highlight it for you. Domain computers, for some reason, was delegated full control on this OU, wherever this OU is. That means compromise of one computer anywhere in the organization would have full control on this OU and all the objects in it. So if this is the OU that contains all the user accounts, or computers, or workstations, or servers, that can be quite problematic. So there are ways to get OU permissions report. We can use PowerShell, which is my favorite way to do it, because I love PowerShell. And so in the slides, which I'll put up on AD Security later, I have a PowerShell link on how to use PowerShell to develop and put together this OU permission report. And we can filter off of this in Excel, because it just outputs to a CSV, what those rights are and what those identity references are, those groups, those accounts that are custom, the ones that are not the built-in ones. Just by looking at those, we can highlight and go, well, that looks weird. That shouldn't be that way. Why is that configured that? How come is Help Desk Tier 1 and Tier 2 have those full control rights? Generic all is full control. And then there's a tool that was released called ACLite by CyberArk, and it goes through and does a lot of this work for you, which is great. Now, ACLite leverages Invoke ACL Scanner, which is a function written by Will Schrader, and it is part of PowerView. And so Invoke ACL Scanner will scan through the OU or the domain or OUs and look at the permissions, and depending on how you configure it, it'll give you information on what the OU permissions are and how things are delegated. ACLite speeds this up and makes it much easier because it leverages Invoke ACL Scanner and then spits out a bunch of reports like accounts with extra permissions or all entities with extra permissions, so groups, accounts, computers. And then there's CSV reports that show up. So it's a batch file, you run that, it does some PowerShell, gets the information and gives you reports. Makes it easy. And then there's also Bloodhound, which is a little more complex, but if you've used Bloodhound before, it gathers the same sort of information. It used Invoke ACL Scanner as part of the PowerShell ingester. Now it uses a C# ingester. And I have the links here, and again, those will be in the slides. And there's also the AD ACL Whitepaper that was written by Andy Robbins and Will Schrader, who spoke at Black Hat last year, more about if you're interested in AD ACLs and how they work. So if you want to effectively detect attacks on your network, there's a few different things you can do. First of all, you want to make sure the logging is appropriate. Way too often I found domain controllers don't have the best logging or are not configured appropriately with logging for Active Directory. So there's this attack method called Kerberos Sting, which I mentioned earlier, which is very simply, you look for all of the accounts in Active Directory, all the user accounts with service principal names, which is required for Kerberos to work for authentication. And once we identify all those user accounts that have associated service principal names, we're going to request service tickets for every one of those. Once we get those service tickets, well, first of all, we need to make sure that they're encrypted with RC4. What's special about RC4? Well, the NTLM password hash is what's used to actually encrypt that service ticket. So if you take that service ticket that's encrypted with the NTLM password hash, we take that offline and we can attempt to crack it. So Tim Medine figured this out a few years ago and spoke about it at DerbyCon, released the Kerberos tool. And in this very simple, basic PowerShell script, I effectively did this. I went through and identified what those accounts are with service principal names and then requested service tickets for each of these and got a service ticket for every one of those accounts. Then I just take those offline. I run a dictionary word list hybrid password cracker against it. It's going to create an NTLM password hash and then attempt to open that service ticket. Once it opens it, I'm golden. I know what the password is. And for service accounts that were created and have had passwords that haven't changed in, I don't know, 3 years, 4 years, 5 years, 10 years, I don't know about you, but passwords I created 10 years ago were awful. Passwords I created 5 years ago were slightly better. A little better today. Horse, staple, battery, horse, battery, staple. Yeah, something like that. Don't use that, okay? So I figured out how to detect Kerberos Sting by looking at event ID 4769, which is when a user requests a service ticket with specific ticket options and specific ticket encryption. 0 by 17 is RC4. So we filter out some things. We identify that there's other types of tickets that actually use RC4 regularly, so we can filter those out in our environment. And then once we do that, we can identify that someone like Joe here at 9 o'clock is Kerberosing the environment. At least he's requesting service tickets for all these different services. Okay, Sean, but what if the attacker doesn't do it all at once? That looks really suspicious. I see that. That's obvious. But what if they do it over days or weeks or months because they've got plenty of time? And these service account passwords don't change anyway, so it doesn't matter. Okay. So I figured out that we could actually honeypot this. We can create an account. I call it here Kerberos Honeypot. I recommend that you use something different. I set admin count to 1, which makes it interesting. Any account with admin count set to 1 is a probable Active Directory admin account because of the way that Active Directory works in protecting domain admins, administrators, enterprise admins, schema admins, etc. And so I create a service principal name. I created the service principal name. It does not exist. It is not valid on the network. It does nothing. So there's no reason for anyone to ever request it. So of course someone does. We look for a user account with admin count set to 1, service principal name set, and then we go ahead and go through and Kerberos it. And hopefully they don't look too closely at what my service principal name is, because then they figure out it's actually a trap. But you can see at the bottom, it's the session key type is RC4 HMAC. So it's RC4, it's encrypted with that MTLM password hash. And so now I run the same detection, and look, there's the Honeypot account. Well, that's obvious that something malicious is going on. And if we take that one step forward, I don't even have to look for all the 4769s. I just have to look for that one. Once I get that one, I know that someone's doing something they shouldn't be doing. Well, and then I went and took this one step further, and I was like, what if I could prevent this? What if I set these two options on the service count that say supports AES 128, supports AES 256? So I did that, and guess what happened? Now I get an AES Kerberos ticket. Now, this isn't going to break everything. There are still ways to request an RC4 ticket, but the standard method of Kerberos Sting breaks, and most of the tools that use Kerberos Sting breaks. So if you're able to set your service principal, your service counts, that obviously user accounts that have spins, if you're able to set them for AES, I highly recommend you do, because it does break the attacker's normal playbook. So password spraying is something that is very popular, and attackers absolutely love doing this, red teamers, pen testers. The whole concept of an account lockout for user accounts was built around the concept that you can only guess this many accounts, and then I'm going to lock out that account. Well, what ends up happening with lockouts? I lock out my account because I only realized on the 4th attempt that my caps lock was enabled. And then the next one I flubbed it because someone said my name. Now I have to wait 30 minutes. Okay, long coffee break. All right. Well, attackers figured out that they could use something that's either called horizontal password spraying or just password spraying, where we take a list of possible passwords, like summer 2018, and we attempt that one password against every user account. And the odds are we're going to find one user account that has a bad password in an AD environment of 5,000, 10,000 users. And so it goes through and does this. And it's easy enough to look at the lockout threshold. It's 5, so guess what? I'm going to do my n minus 1, 5 minus 1, 4. So I'm only going to do 4, and then I'm going to wait. And I can also enumerate the fine-grained password policies, because those might have different policies for lockouts. So I can look at those also. And then pick lowest common denominator, and then I know how many passwords I can tempt in the environment. This works. This works well. In my lab, my fake users are horrible at picking passwords, let me tell you. I'm going to fire all of them. Terrible. I thought I told them not to use password. So they're like, password 1, we're going to use an ampersand. But through my lab environment of 1892 users, perfectly random number, connect to an SMB share or a network service, and then so I just decided to target the PDC's netlogon share to do this. And it didn't take me long to write this PowerShell. I'm not a great person at writing PowerShell. I do okay, but I'm not a developer. It took me a couple hours to write this. So that means anyone can go ahead and do this. It's not that difficult. But when I go ahead and run this password spraying script that I wrote, there's a bunch of 4625s, bad password attempt against this account. And so this happens across all of them. But I also figured there's an attribute in Active Directory called last bad password attempt. At least that's what it's called in PowerShell when you use the Active Directory PowerShell commandlets. So I looked at that, and I'm like, that's pretty obvious that someone's doing something odd. So we have a couple different ways to detect this. 4625s, which most organizations are logging on their domain controllers. And we can look at the attributes in AD, which any user can do. OK, that's great. But then I switched to LDAP. And when I password spray against the LDAP service on the domain controller, guess what happened? All those 4625s just disappeared. OK, so this means that organizations that are looking at 4625s for password spraying are completely missing a huge attack vector. OK, but there's got to be a way to figure out that this is happening, right? Well, there is. So I ran through, again, my environment, again, complaining to my fake users about their bad passwords, and saw that the Kerberos authentication service event got logged 4771. This one's pretty boring, so I went back to my attributes and I saw, yeah, last bad password attempt was definitely flagged there. Great. Bad password count, by the way, is per domain controller. So if you have an environment with a ton of domain controllers, this isn't as effective because you'd have to parse all of them to figure out bad password count. But I show it here as an example. So I looked at that 4771 and it's Kerberos pre-authentication failed. Well, most people don't care about pre-authentication failed. And then I looked closer and saw this failure code, which is 0 by 18. And when I looked this up, guess what it meant? Bad password attempt. So now we have a way to detect password spraying no matter what's being done in our environment, which is great. The other thing I identified is that on endpoints, on our workstations, if someone's doing password spraying from that, we can look for 4648 event IDs, and we can see that there was a logon was attempted using explicit credentials. So Joe is doing some very shady stuff because he's attempting to authenticate as all these other users. Joe is another fake user that I need to talk to because he should not be doing that. So, what's the next step? What do we need to do? And I have a bunch of recommendations here. I know it's a very busy slide, but this encapsulates all the some of the primary recommendations that I make to customers when we're looking at their Active Directory environment. Some of the keys to this are limiting who your Active Directory admins are and making sure that they're using some protected method to ensure that their credential is well protected and not leaked in the environment. If they're using a regular workstation and then RDPing to a domain controller, that's not the best way to do it. It's much better to use an admin system, like an admin workstation, to move it over to isolate that credential from the standard workstation. So there are things that matter, making sure the local admin passwords change. Host firewall on your workstations is one of the most positive things you can do in your environment. If you get a host-based firewall like the Windows firewall enabled with default inbound rule blocking on all your workstations, this will incredibly frustrate attackers. It will have much more impact than buying the security tool with the blinky box. Sorry, people out there. It has tremendously positive impact. And guess what? The ransomware that uses WannaCry or any of the new names of the month of how SMB worms are being called or how they're working, it blocks that too, because they just can't jump from workstation to workstation, which is what they've been doing. It has a huge positive impact. There's no need for workstations to talk to each other. And workstations also don't need the ability to have a domain controller reach directly to them. It has a stateful firewall. The Windows firewall is stateful, which means that when the workstation reaches out to the domain controller responds to it. So you can have the Windows firewall enabled. You can have a host-based firewall enabled in Active Directory. The things that you'll have to look at as exceptions are your management products, your patch management products. Administration. Much better to have an admin subnet that those are going to come from, so that way when they reach down, they're allowed through that firewall rule. So we want to make sure that we are firewalling and protecting, limiting the communication between systems that need to have communication between them, and restricting and preventing communication from other systems that don't need it. And then disabling old and uncommon features and protocols really matter. Things like getting rid of LM, NTLM, shifting up to NTLM v2, turning off SMB v1 in the environment. LLMNR is usually not required, so disable that. Things like Responder, which I call the easy button for pen testers and attackers, will just siphon and suck up the credentials in the environment on the network when these things are enabled. So that's been my time. Thank you so much for yours. I do have a few minutes for questions if anyone has questions. Otherwise, I'll be over here if you want to follow up. Question, yes?
Yeah. So regarding service accounts, where do you see group managed service accounts sitting in terms of your recommendation?
Group managed service accounts are fantastic because AD manages the password for it, and that changes about every 30 days. Great. One of the challenges with that is there's certain applications that don't work with GMSAs or MSAs. But yeah, I would absolutely love to see more service accounts using that because the passwords automatically get managed and rotated and are long, complex. Absolutely. Anyone else? Okay, great. Thank you very much for having me at ChakaCon again. Okay.